Hello everyone, I am Prabhu Bain Marad, Assistant Professor, Department of CSE, BLD CET, Vijaypur. In this video, I am going to discuss about the Poisson distribution. So, the Poisson distribution describes many random processes quite well and is mathematically quite simple. The PMF of Poisson distribution is given as P of x equal to e raised to minus alpha, alpha raised to x divided by x factorial. So, where x equal to 0, 1, so on, and it is 0 otherwise, and the cumulative distribution function is given as capital F of x equal to summation I equal to 0 to x e raised to minus alpha, alpha raised to I divided by I factorial. So, here the value of alpha is greater than 0 and mean of Poisson distribution, that is E of x equal to alpha, and variance is V of x equal to alpha. So, in case of Poisson distribution, the mean and variance both are same. So, let us solve the problem. A computer repair person is beeped each time there is a call for the service. The number of beeps per hour known to occur in accordance with Poisson distribution with mean alpha equal to 2 per hour. So, find the probability of 3 beeps in a next hour and probability of 2 or more beeps in a 1 hour period. So, this is a problem related to Poisson distribution. So, here they have given the average number of the beeps so occur in a system that is 2 per hour. So, we need to find what is the probability of 3 beeps in next hour. So, that is where alpha equal to what here 2. So, this is calculated by using this particular equation. So, that is probability of x equal to e raised to minus alpha, alpha raised to x divided by x factorial, where x equal to 0, 1, so on. So, the value of x is we have taken it as what here 3, because we are finding the probability of 3 beeps in next hour. So, x is what here 3. So, that is e raised to minus alpha. So, that is alpha value is what here 2, and alpha raised to x is nothing but 3 divided by 3 factorial. So, after evaluating the equation, so we get the final value as 0.1804. So, this is what here the probability of 3 beeps in next hour, and the probability of 2 or more beeps in next 1 hour period is given as that is probability of x is greater than 2. So, this can be computed as 1 minus probability of less than 2 beeps in the next hour. So, that is 1 minus probability of x is less than 2. So, this is further computed as the probability of 0, the probability of 0 minus probability of 1, or the probability of 0 plus probability of 1, and after calculating these two values, that is subtracted from 1. So, this is for calculating the probability of 0 and this is calculating the probability of 1. So, we get these two values are subtracted from 1. So, the final value is 0.59. So, the probability of 2 or more beeps in next 1 hour period is 0.59. Let us solve another problem. So, the number of hurricanes hitting the coast of the India follows Poisson distribution with mean alpha is equal to 0.8 per year. So, determine the probability of more than 2 hurricanes in a year and the probability of exactly 1 hurricane in 1 year, right. So, first we shall find out the probability of 2 or more hurricanes in a year. right. So, the probability of more than 2 hurricanes in a year can also be computed by, that is 1 minus p probability of x less than or equal to 2. So, that is the number of the hurricane less than or equal to 2. So, first we will calculate the number of the hurricanes which are less than or equal to 2, and that is subtracted from 1. Okay. So, the probability of hurricanes less than or equal to 2 is nothing but what here? The probability of 0 hurricane, the probability of 1 hurricane, and the probability of 2. So, all these will be calculated separately, and these values are added, and after that the obtained value is subtracted from 1. So, finally, we will get a value that is 0.07. So, the probability of more than 2 hurricanes hitting the coast of the India is 0.07, and the probability of exactly 1 hurricane in 1 year is nothing but p of x, the value of x as what here? 1. So, that is e raised to minus 0.8, 0.8 raised to 1 divided by 1 factorial, that is nothing but 0.359. Thank you.